So, I want to explain a little bit about the system.
Yeah.
So we have three separate parts. It's like three rooms. So we have this part is the main room of the machine, and this is the VSC. You can open this part by this icon. Double click on this, you will open this part. What we do in this part, we launch the program. So this part is made for launch the program or list of the program. So you could have several programs to do today, and then it's possible to do, of course. And the other thing that you do in this part is make the set point of the machine. The set point of the machine is the starting point. So the machine has to know where it is. So every time that we switch on, we must make the set point. So you must have the power on the machine, and then you press here and you have the possibilities to set the machine. This is your starting point. The machine will move in every axis and find the right position, the starting position. Okay, so from this part you can open everything you need, and you have three rooms. This is the first room that you have. The second you can open by show, for example, this albatross, and albatross is the black one. And what is this part? This part is very important because you can move manually the machine. Like in this case, I push on the axis, and if you need to move the machine manually, you can do in this way. So you can select the axis, you can select the speed, and you can push minus or plus, and the machine will move in one direction or in another direction. In albatross, we make also another thing really important, and is the tool parameters. The tool parameters are, for example, when you have to create or modify one tool that you have in the machine, you can do by this list. We will see together how to create a new tool, how to delete whole tool or modify some tool. Because if I go inside, I can modify all the parameters that I have.
And this you have to update sometimes.
Yeah. So, for example, we can delete, we can move. Of course, it can happen the knife or the emitter of the tool is not correct, because it's not 15.5, but it can be 15, for example. And then we can make some modification on tools. Okay. So this is the second part. So I repeat, on albatross we make the movement of the machine manually, or we can move also or adjust or create new tools on the machine. Of course, albatross do a lot of things more and more, but for the moment this is what is important to know. The third room is this. So from tools, I open this.
Hello?
Yeah. Hi, Nicholas. Hello?
Hello?
Okay.
Try
So,
to connect with my headphones.
yeah, okay. So, let me see one thing.
Now
Okay.
with you all.
Thank you.
I'm here.
Okay, hi Nicholas.
Hello.
Hi. Are you in front of the machine or also you or not?
Yeah, I'm beside
Okay,
Jakob.
okay. So I just opened also the CAD system. So I repeat just one thing very fast. The system is done in three separate rooms. In the first room we have a VSC, boot system control, is this one. In this room you can open Albatros in this way. If I push, I can see the black one came here. And Albatros is made for make two things: move the machine automatically or switch on and off some drill bit. For example, this is the bit inside, outside, and so on and so on. Or I can move the machine where I want manually. And I can also adjust or make new tools, for example, like this. I can modify the tool, I can create a new tool, I can delete the tool, and so on and so on and so on. And the third part is the CAD system. So I can open also by ear, no problem. So I can push here, TPA 8032 is the software that we use to make drawings directly on the machine. And that's it. So the three parts, the three rooms are connected all together, of course. And you can decide what do you need. Of course, the VSC you must be open every time that you switch on the machine. Is the first important step. You must have open the VSC every time. And I repeat, the VSC it's used for open the two rooms, Albatros and TPA 32, or it's used for launch the program in this page. To arrive to this page is very easy because when you go to modify and new, and so a new work list will be open. In the list, in this moment we don't have any lines, but we can open the lines here. Every line that I open is one program. For example, if I want to load a program in this line, I go in here inside in this part near under to name, double click, and the system asks me to choose a program to be done in the machine. For example, this one. And now I'm ready to produce this part. For example, one pieces or more pieces is also possible to say. X means the execution. So when for example, I want 10 pieces, and when I start the machine, I will see here for every piece done, 1 and then 2 and then 3 and then 4 up to 10. When the request number of amount of the pieces is the same like the executed programs, this line is done, and I go down in another line if I have. Okay, this is the area. So where I want to produce the piece, because in the machine you have several areas. In your machine you have two areas, A or B. Okay, in this condition, if it's set AB, means you're working on the left side of the machine. Otherwise, in this way, BA means you work in the right side of the machine. Okay, and this is another argument that we will speak about. The mirror can be automatic or not, and it depends if you want to produce the piece in the same way that you program, or you want to rotate the panel 180 degrees. like assembly cabinets. You could have left and right parts. With this parameter, you can move it as you want. And then you have the dimension of the panel, so length, height, and thickness. So you have some information here that it's important to know. Okay, so in this part we launch the program or we make the set point. In automatic I can make the set point. As I told you, it's the set point is the first thing that you have to do when the machine is switched on for the first time in the day. You don't need to make several set points in one day. Just one is enough. Up to you don't switch off the machine. Okay, in this page you can open, I repeat, Albatros and then also the TPA 32. Okay. Normally I used to have the three rooms, the three icons every time on background. So one is here, one is here, and the other one is here. So I can use what I need in every moment. So I don't close Albatros, for example, because it can be that I must open in 5 minutes. So don't close it. In my opinion, it's the best. It's not a mistake if you close, but doesn't make sense in my opinion. Okay, so now we have to understand a little bit better what can be interesting for you because of course we have to think about that you will work on the machine software sometimes because we have some good things inside in the machine to program. So it can be interesting to understand and to know how to program directly in the machine software. Of course, you have also AlphaCam. So part of the program can be done also in AlphaCam because maybe for program something it's very easy and fast. Okay. So I want to concentrate a little bit to show you what happened in the machine. For example, I open a new. This is a new, completely new program. Let me see. Yes, it's a new program. So this is like when you open a program, what you have on the screen, the first page. And on the first page you have the size of the panel. Of course, really important. You have all the information here for the panel size. I can, of course, modify everything and. Okay, and you will see the panel will change in dimension. In this screen, I cannot do anything. I cannot work. I can just put the parameter like this. I can put some parameter also here. We will see in the next future. We will see also this parameter. But I cannot put, for example, bore, or drill, or routing. I cannot do nothing because before I must choose for the face where I want to work. And here you have the faces. This is the main. If I switch on this, you will see this is the main face. So on the back you have the caps. We have the system for vacuum. And this is the top of the panel. So more or less all the times we work for sure in the face number one, so this face. Can happen that you work also in the side left or the side right or up and or down, can be. And we will open and switch the face that we need. Okay. So just to show you that the program it's more or less easy, okay, like AlphaCam. If I want to make a hole, for example, I can see here I have 3 possibilities to work in the machine. Hole is this, so every kind of holes that you have to do with the boring head, you go in this first icon. You have inside several ways to make holes, but anyway it's holes. The second one, it's when you have to use the router. You have two possibilities. For the moment, we just use this. And the third is this. This is the blade. And the blade can be done by the boring head or by the router. It depends. Okay. So I come back to the first one, and I want to make a simple and easy hole, just one. I select this, and I can see on the left side that I have some parameters to put. And the parameters are the dimension in x, I mean the dimension in horizontal x. So where it is the hole in x, for example, 100 millimeters. In y, it's how many millimeter I want to put the hole in y, for example, 50. And z, it's how many millimeter I want to go inside in the wood. For example, with the sign minus 10 means I go down 1 centimeter inside in the wood. Then I can put the diameter, for example 10, and I confirm. And this is the first hole that you do. I can use the zoom here or the palm to move it. So I can zoom in this way. I can zoom by window in this way. I can zoom all the parts. So the camera will be outside up to I can see everything I have in the drawings, and so on and so on. And this is just one easy hole. If I have to make another hole, for example here, I can call another time hole. If I push again, I have a completely clean here, and for example I want to do 500 millimeter, 100 millimeter minus 10, and then diameter 10, for example. And I have the second one.
Yeah. Is this necessary? Because isn't this done in CAM already, in Alpha CAM?
Of course.
All of this.
The point is, Jacob, the point is, if you know how to use both the tools, so AlphaCam and this,
Yeah.
you are more powerful.
Okay.
So, in my opinion, if you know, you will use both. This is my opinion. It's your choice, anyway. So. Of course,
Yeah.
but I think it can help you also to understand better what is the way to think about the machine, think about the work that it has to do. So it's a little bit important, in my opinion, to know.
Okay.
After you will decide if you want or not, but yeah.
Yeah.
For example, if you have to make something like this, maybe better to pass through AlphaCam because it's faster.
Exactly.
Yeah, it is. And also, my opinion, we don't have to make something that can be complicated or long, or you have to make a lot of calculation. Okay, you have AlphaCam, so we use it for sure.
Yeah.
The problem is sometimes if you have to make some very fast, for example, a little panel with some holes inside, I don't think you pass through AlphaCam for this.
Yeah.
Because the machine maybe the machine is faster.
Yeah.
Why is faster? Yeah. Why is faster? I want to explain better now. Soon happen that we have to program something that more or less is the same, but just change the dimension. About this point, Niklas can tell you that it's very, very often it happens in carpenters. I want to show something. This is just an example, but I have, for example, to do something like this, and I put some more holes inside. For example, I have to put 4 holes in the near to the edge. For example, the first one was the first hole was 150 millimeters from the edge, because this is my 0 point, so everything will be the reference is this. And I will do the same here, so one hole here, one hole there, and one hole there, okay? Of course, I can write down, I can take another hole, and I can say, okay, my panel is, I don't remember, I have to come back here, it takes time, just a second. So I come back here, and it's, okay, it's 2000 millimeter and 600. So the second hole, because it's here, I can do something like this, and it's 2000, so it's 2000 minus 100. And the y-axis is like this, and that is like this, and the diameter is like this. Sorry, the y-axis is wrong because it was 50. Of course, if I use this system, it takes a lot of times, and I have to remember a lot of things. And maybe if you work in this way, it's wrong to work in the machine in this way. What is the right way to work is this. Also because when I change the dimension of this panel, this is what happened. For example, I have another panel, it's 150. Of course, the holes that I programmed before, it's here. Doesn't follow the changement in the length. So the way to program in this way is completely stupid, and you don't need to work in this way, of course. But the program that you have in the machine, can be very clever. I explain it a little bit better. The position in X, I can use the parametric way. What is the parametric way? I can use the length of the panel to make the measure. I mean, when the panel was, I come back in the length 2000 millimeter. I switch on the first phase. Now, if I put just the number 1900, of course, will be in this position every time. It doesn't depend about the panel size. It will be anyway in this position. But if I write something like this, LF minus 100 means long of the face minus 100. So this means with just one program, I can manage all the programs that I want. If I have to make another program like this, follow me. So I can manage everything in a really, really short time without to make another new program. That is. So for example, I want to produce four holes. So another ear and another ear. Of course, I can also copy and paste if I want. For example, if I press the shift in a keyboard, I can make a selection of everything, and I can Ctrl C, Ctrl V, and I just, in this way, I copy the four holes. So what I have to do now is just go inside in this line, and this configuration. When you select this line is anyway this configuration. So select the line that you want to make some modification and then modify. And for example, this all will be LF minus 100 and HF minus 50. And it becomes this, and then I go here and I can say, okay, it's 100 and HF minus 50. In this way, if I program in this way and I understand how to program in this way, it makes a lot of sense because it's really fast now. If I want to modify the position, the dimension, no problem. I can modify as I want my system, and everything will follow me So this
That's
is this,
useful.
this is what AlphaCam doesn't do, or better, you can do also by AlphaCam this position, but it takes a lot of time.
Okay.
So we use the TPA software when it's clever, and we use AlphaCam when it's clever.
Yeah.
Okay. If you have two tools and we use two tools in the best that we can do, maybe it's better. Is the best for you. Okay.
Can I ask you something? Can I just ask you,
Yeah.
what, when you pasted it, Control
Yes.
C
Yes.
and
Right.
Control
Right. Right.
V,
Of course.
is it C and V?
Right. You have two ways to paste, Nicholas. For example, I want to copy this line, just one, for example. Of course, Control C, Control V is the Windows short command. Okay, it's standard. But you can also make it this way. You don't, if you forget it, you have here
Copy, okay.
and paste. And what you copy and paste what is selected in that moment. For example, I can also, the selection in TPA, it's very important to know the selection. How to select some parts, for example. I want to say, if I want to make a big window and select what is inside in the window, I have to press the shift on the keyboard and then make a window selection like this. And you can see the selection in blue. So in this moment, if you want, I can copy and paste this selection. Or I can just push here, sorry, I can just push here and I'm selecting this line. Or another way, for example, there is the possibility to select this and this. Yes, of course you can. You go on the line, for example, the line number 2, and you keep press Control on the keyboard, and for example, the number 4, and Control in the number 4. So in this way, I select the 2 lines that I want in my list. And if you want, you can say, okay, copy. I go on the last line and then, sorry, paste, yeah. So now I copy these 2 and the line became 6, was 4 before. Okay, so the selection, how to select, how to copy and paste, it's really important to understand. As I already told you, today is not a really lesson. I just want to show you something. Okay, tomorrow or the next week we start with some particular things. So the lesson will be better and better.
Exposure for.
Yeah, today is just a meeting, you know. But anyway, also this lesson will be. I will give you the link on YouTube, so you can see and hear all the parts that we in this lesson today. So you have the time to understand better and better, because otherwise it's not easy to write down everything and to remember everything and to make some exercise after. Okay.
Exactly.
Okay, so today I want just to show you something about how to make the bore, how to make, this is a parametric, for example, bore. So I'm using not just number, like in this case, for example, this bore, I don't need to use LF or HF in the position, because the reference is this. So because of this all, it doesn't matter if the length of the panel is more or less, because normally I use this in this position. What I have to, the board that must follow me in the panel size dimension is this, this, and this. Okay, I move the dimension and I will show you something else. Huh? For example, I make a square. Okay. Now, is it possible to make holes also in the side? For example, this side. of the panel. Yes, of course it's possible, the machine can do it. How to program this? Very, very easy, because it's enough that you go on the faces of the panel. You can see here. For example, this, it's called face number 6. If I switch on the face, you can see here the face is this. And you have on the, it's like the program, it's like you program in the face number 1. So now everything is like in the plane, in the standard plane of the machine. And same situation, I opened my hole, and I want to make you can see here the system now, this is X, every time this is X. For example, 50 millimeter from the bottom. This is why we know that this is the thickness of the panel, but for the machine this is why. So if I want to put the hole in the middle, and I want that every time every thickness will be in the middle, I can write like in this way. So it's HF, so the height of this face, divided 2. And the Z is anyway how many millimeters you want to go inside in the wood. And if you remember, we need the minus behind. So it's minus, for example, 10. And then the diameter, for example, 10. Or 12 or 8, what do you have? And I make 1 holes. If I check, is this the hole? Okay, I come back in the same phase because I need another holes in the same position, but here. This is can happen often that you need 2 holes in the same position. So of course I can take my panel, I can write down, or if I want to save time, I copy and paste the same hole. So now I have 2 holes. And the second one, I just say that it's LF minus 50. LF minus 50 will be here. So I come back, I check for my 2 holes are okay. And I want to copy the same hole in this other face. The phase is called number 4. So I come back in the 6. I make a big window and I copy. I switch the phase in the number 4 that is completely empty in this moment. We don't have any kind of holes inside. And I paste. Really easy. So you have the result that you have 2 bore in this part and 2 bore in the other part. And the good thing is, if I change my dimension, no problem, because everything will follow me automatically.
But it's not usual to work on the side on like in carpentry.
Sorry?
It can be very useful to work on the side of the wood.
Yes.
It's more common to work straight on, like
In the machine. In the machine, you mean in TPA?
Yeah.
Yeah. I don't know if it's. I don't know if it's easy than AlphaCam or not. It depends. Maybe it's not. But the point is that it's very fast.
Yeah.
Also in AlphaCam it's not difficult, but here you can produce, for example, a cabinet with all the holes and everything you need to produce a cabinet. And when you modify just the dimension, but the cabinet is more or less the same, you can produce all the program in 1 second. So this is because it's very, very powerful in my opinion. Okay, so we come back in the first page. Now, what we can add in this moment, for example, if you want to make a repetition of the hole, it's really common in Italy in the cabinets. You have a lot of hole here with repetition on the Interact 32 millimeters. And I can do here, yes, of course, you have the possibility to do everything. So for example, this is called fitting. And in the fitting you can, for example, decide the starting point, I don't know, 200 millimeter, the final point, I don't know, LF minus 200 millimeter, the interact between the holes, and the height on the y-axis, for example, 200, the depth and the diameter. And this is the repetition that you have.
Okay.
You can modify, for example, the interacts. So in this way, it's 40 millimeter. If you use 32, means that the machine can bore several holes in one time, and it depends. It depends by you.
Useful function.
So on TPA you have all the features that you need to produce panels. AlphaCam is made for do everything. Also, really without any limits. But in the machine you have all the things that can be clever to produce cabinets and so on. For example, if I want to copy this on this part, I can copy and paste, and the second one I just move the y-axis, for example here. Now it's I can yeah, it's 500, for example. In this way I increase the height and so on and so on. If you need to make a cut here, for example, because of the back of the cabinets, you can use this. This is the blade that you have in the machine, in the routing, in the boring area you have also the blade. And the blade, I ask you for the first point, for example, minus 50. Final LF plus 50, because it's completely a cut that want to go from the left side to the right side completely. And for example, it's the position in Y can be HF minus 20. Minus 5 is the depth, and this is the cut. And when I change the dimension, no problem, because everything will follow me. So it's, of course, it's really powerful, the system. Okay, now, for example, for today it's enough. I want to save the program. Okay, how to save the program? I go in File, Save As, and I choose for a directory where I want to save this program. The system say want to bring me in this directory, the product directory. Okay, this is the default directory. It's not a problem to put, for example, in another place. For example, I produce a new directory here. I will call training TPA. And this is the first program. And the optimization of the machine say that I have some mistake. So when I save something, the machine will understand, will check if I have all the diameters right, if I have all the boring bits right, and so on and so on. And of course, I wrong. Is not in the phase number 6. I don't have the right diameter. Of course, because I don't know the diameter that you have. But anyway, the program is saved.
It's
So
safe.
yeah, if the mistakes appears, doesn't means that the panel. Anyway, I have the program here. So no problem. Of course, it's not possible to execute this program. If I go here and I change directory and I want to produce this panel,
Yeah.
I can load, but it's not possible to run it. For example, okay, the system show me a little bit some information. I open, okay, it's here, but when I push for start, the machine tell me that there is some mistakes and will not produce this panel.
Okay. Interesting. Nice. Okay.
Okay.
That's good to rely on if you don't have to feel scared of doing something.
Okay.
Because the machine knows. Yeah.
And okay, another thing can be, yeah, we have some minutes and I want to spend some minutes because of this. Let me see. I come back to the first page, to the first phase. The fitting that we try to use, the starting point is 200 millimeter, so this is the first one, and this is the last hole. I ask for the last hole LF minus 200, but I also ask for the Interax 32 millimeters. So my question is, do you think this hole will be, the position of this hole in the y-axis will be really at LF minus 200? Can be possible in your opinion?
No.
Yeah, right. Because I tell to the software too much thing, because I ask for the starting point is
So on the
200.
left.
And this is 32 millimeter up to LF minus, and what happened here? Happened that at LF minus 200 will be make a line, vertical line, so the system doesn't go over this line and keep the 32 millimeter of Interax. So if I want to understand what is this hole, I can also try it, because it's possible to measure everything. Let me see in your version here.
That's interesting.
So I can for example, I can go near to the hole and I see it's 300 millimeters. And if I want, I can also switch on the snap on the programmed point. So this point is 296 millimeter in the y-axis. 296 is not LF minus 200, because LF minus 200 is 300. Is not 296. But the system make something like this. Let me check. Yeah. This is my panel. I asked for some holes, and LF minus 200 means the system put a line here where it's not possible to go over this line. So I have all the bits here, but when I came, but not over. So the difference will be from 0 up to 31 millimeter in the last one. It's clear, Jacob, more or less.
Yeah.
Okay. Okay, but we come back to this point if you want. This is maybe sometimes it's not clear in the beginning, but I will explain you better. If you have, for example, if you have some parts, some cabinets to produce or something to do in the machine, give me some drawings. We can do together. So we have some sample from you. Okay. Okay, so for now, for this moment, it's enough. So you have some information, of course, it was just a presentation today, not too much, but... And then, in the next step, tell me when can be okay for you to have another connection. In this time, I give you, to you and to Niklas in WhatsApp, the link for this lesson, so you can, if you want, you can, yeah, you can take a look again. And yeah, that's it for the moment.
Can I ask you something?
Yes.
When do you go
Yes,
home?
yes, yes. Of course.
When do you go home in the afternoon? Is it possible to have the lesson 4 o'clock to 5 o'clock?
Yes, it depends about the day, but yes. For example, let me think about. For example, tomorrow can be okay. Tomorrow can be okay, for example, no problem.
Okay. Why I'm asking you is because people, they go home 4 o'clock.
Ah, okay, so it's the noisy.
Yeah.
Not too much. Okay, no problem. If you want tomorrow and Monday, yeah, right. Tomorrow and Monday, if you want, we can fix on between 4 and 5 o'clock. No problem.
Okay. We're gonna go and get this AlphaCam key tomorrow.
Oh, good.
So I don't know.
Good.
So then we have that. So then that's maybe
Yeah.
Monday instead.
Perfect. So if you have tomorrow, we can make a connection tomorrow if you have time between 4 and 5 o'clock. And then in the same hour, we take route a little bit to the TPA, so to the machine. But we can also make an upgrade for AlphaCam in your computer.
Okay.
So we can do together tomorrow if you have time.
But when do you start drinking the wine?
After 5 o'clock.
After 5 o'clock.
5 and 1 minute, it's okay. Not before. No, it's okay for you tomorrow, or it's better Monday, as you prefer, huh?
Say Jakob.
Yeah, I can. I mean, I'm very like dynamic with the time and everything, so it doesn't matter for me.
But you want to do it tomorrow?
Yeah, I want to do it tomorrow, and 4 o'clock is better.
Otherwise, if something changed for tomorrow, just you make a message tomorrow morning. So for now, we rest that we meet tomorrow between 4 and 5 o'clock. But if something change, you write me in a WhatsApp message and say, okay, no, we move on Monday, for example, and it's okay also Monday.
Okay. Another question.
Yeah.
I don't know Jakob so well because he has AirPods. Can you hear him?
The AirPods.
Jakob?
Ah.
I just wanted to know if you can hear Jakob. I have a problem to hear him.
Yes, also me. Not really easy to hear Jacob. Yeah, yes. Also to me it's not very easy. Yeah.
Okay, because I have like a headset with a microphone.
Ah,
I'll
okay.
give him a pair.
Okay.
I think it'll be better tomorrow.
I
Yeah.
couldn't start them. You gave them to me, but I couldn't start them, so.
Okay.
I was in a hurry.
Okay. If you have something, yes, like AirPods or something like this, maybe it's better. That's right.
Yeah.
Okay.
Okay, guys.
Thank you very much, Damiano.
You are welcome. I hope this way it's okay for you, and of course it takes maybe some time, but some hours. But I think we can arrive to have a good training for you.
And I think I understand quite much of the things you went through, so I can explain to Jakob if he has any questions also.
Good. Check off also for the video of today, and maybe also this can help. Otherwise, okay. But tomorrow, if you have time, we go on with fall.
Okay.
Okay.
Thank you very much.
Okay, to you, of course.
Have a nice evening.
You too. Thank you very much. Bye.
Bye-bye.
See you.
Bye.
Bye. Bye.